welcome back. This is the second part of the lecture for Wednesday, the 25th. So we started with 7.3, so if you have not yet watched the 7.3 video, make sure you watch the 7.3 video first. Now we are on to 7.4. 7.4 covers multiplying and dividing radical expressions. So I want to start by doing 4 examples that I've put up here. These examples are from the 7.4 study set, so if you would like to follow along, turn to page 626. So let's start over here with number 16. How do we multiply radicals? Well, it's pretty simple. We just use the product rule. 5 times 15 is 75, so when we want to multiply root 5 times root 15, we simply combine them to have root 75. In other words, what I've done, and you don't need to show this step, but what I've done is I've combined 5 times 15 in one radical, like this. Okay, that marker doesn't work. Let me try another one. So, equals. Remember, if you are going to show your work horizontally, you need to connect equivalent or equal expressions with an equal sign. If you show your work vertically, the equal signs are encouraged but not mandatory. Okay, so you do not need to show this square root of 5 times 15. You can go straight to square root of 75. But the idea is that you can combine 2 radicals that are the same type of root. These are both square roots. They both must have the same index. The index for both is 2. So now we can combine them. Square root of 5 times square root of 15 is square root of 75. And this simplifies further. Square root 25 times square root 3 is equal to 5 root 3. So first multiply them together. That's the first part of the problem. The second part of the problem is then to simplify using the methods that we learned in 7.3. Okay, so that was a really simple example. Now we're going to move on to some harder ones. Number 20 is going to have us multiply together 2 cube roots. Notice also that there is a 2 on the outside of the first radical and a negative sign on the outside of the second radical. So remember this, that when things are outside the radical, they can multiply with other numbers outside the radical. And when numbers are inside the radical, they can multiply with other numbers inside the other radical, as long as they both have the same index. These are both cube roots, so we can combine them. So the 2 times negative 1, there it is, 2 times negative 1 is negative 2. And next we're going to multiply cube root of 16 times cube root of 4. 16 times 4 is 64. The cube root of 64 is 4. So then we have negative 8. Now you are welcome to just show one line of intermediate work, and that one line of intermediate work would be this line. So you can skip negative 2 times 4. But if you are prone to make mistakes, I do encourage you show more work rather than less work. Okay, moving on now to number 24. Number 24 here we have 3 times the square root of 8x times 2 times the square root of 2x cubed y. So remember, numbers outside the radical can multiply with other numbers outside the radical. So 3 times 2 is 6. And now I'm going to combine these two radicals together. 8 times 2 is 16. X times x cubed is x to the 4th. Y is, of course, just y. Once you combine the radicals, then you can start splitting up the radicals. Sixteen is already a perfect square. X to the 4th is already a perfect square. Y is the only part of the expression that ends up over here. So now we're going to simplify further. Square root of 16x to the 4th is 4x squared. Six times 4 is 24. That's a lot of work. If you don't need to show that much work, show this step right here at least. This is combining the two radicals into one radical. And then skip whatever intermediate steps you need to skip. But you do need to at least show one line of intermediate work here, and it should be this line of work right here. Okay, so now we're going to move on to the distributive property here in number 32. We see the use of the distributive property. The expression on the outside will distribute to the two expressions inside the parentheses. You do not need to show those arrows. The arrows are just to help you see what I'm doing. I'm going to multiply the expression on the outside first by the expression on the inside. Then there's this plus sign, so that plus sign will divide the two products. And then the second part of the expression right here will be the product of the expression on the outside times the second expression inside the parentheses. So here we go. 3 times 2 is 6. And then you don't have to make this too complicated. The square root of 7t times the square root of 7t is just 7t. Seven t times 7t is 49t squared, right? And the square root of 49 is t, and the square root of t squared is t. But the idea is that if you square a square root, the square function and the square root function are inverse functions. What that means is that they undo each other, okay? It's like this. One function is putting the sock on, and the other function is taking the sock off. So if you first put the sock on and then take the sock off, you get your foot back, right? So if you square a square root, it cancels. Let me show you what I'm talking about over here. So if you square a square root, the square cancels the square root, leaving you with the expression that was inside. Okay, so this is just my work off to the side to explain why I was able so quickly to do the square root of 7t times the square root of 7t and get just a plain old 7t. Now for the second half of this problem right here, our second half of the expression, 3 times 3 is 9. And then square root of 7t times the square root of 3t squared, I am going to combine these into one radical. 7 times 3 is 21. T times t squared is t cubed. And then I need to split that up further. So I want to split square root of 21t cubed up. If you can simplify this in your head, feel free to. 21 has no perfect squares that divide into it other than 1. And t cubed splits into t squared times t to the first. Then this simplifies to just t, right? Square root of t squared is t. Now let me point out something very important. 42t and 9t cannot combine here. Why is that? 9t is attached by multiplication to the square root of 21t. So this isn't really a 9t, is it? This is a 9t square root 21t. And 42t is not going to combine because these are not like terms. So do not try to combine these. Remember, PEMDAS, multiplication comes before addition in PEMDAS in the order of operations. Okay, so for the next part of the lecture, I've put up 3 problems. 2 of these problems are from the study set, and the other problem over here, question 15, is from part B of the MyOpen Math homework. This is question 15. So what I recommend you do is I'm going to step out of the frame, and then I want you to pause the video and try all 3 of these problems by yourself and see what you come up with, and then unpause the video and watch my explanation. Okay, so I'll step off the frame, and then you need to pause the video and try each of these on your own. Okay, welcome back. So I'm about to go through each of these, and I'm going to first just work them out, and then I will do a commentary. So I'm going to pause the video right now, and the answers will then magically appear for you on the board, and then I will explain each of my solutions. So first, for number 36, this is a FOIL problem. So what that means is that we need to do first, outer, inner, and last. The first product would be 2 root 3 times root 3, and that gives us just 2 times 3. Outer is 2 root 3 times negative 1, which gives us this negative 2 root 3. Inner is 1 plus root 3, and last is 1 times negative 1, which is of course negative 1. So now I'm going to combine like terms. Here I have 6 and negative 1. And then negative 2 root 3 plus a 1 root 3 is a negative root 3. Okay, next, number 52. Let me first point out that number 52 is not equal to 81 plus 11 or 81 minus 11. When you square a binomial, your result should be a trinomial, which you would then need to simplify further. So instead of this, you should have this. And you use FOIL. First, outer, inner, last. So for this solution, or rather this simplification, we're not solving an equation, we're simplifying an expression. For this simplification, you do not need to write out the product side by side, but I highly recommend it. Then you use FOIL, and then you simplify like terms. Okay, next comes question number 15. You can use FOIL for number 15, but it's better if you can identify that we actually have a difference of squares. Notice that the first expression, 6 root x plus 7 root y, matches a plus b, and the second expression matches the form a minus b, and a plus b times a minus b is a squared minus b squared. So what we can do is take the a term, 6 root x, and square it, and then use the subtraction sign here, and then we square the b term, 7 root y squared, and we end up with this. This one does not require any work, okay? So if you can identify this as a difference of squares here and go straight from here to here, that's wonderful, okay? So next, let's look at some other problems. I want to look next at the topic of rationalizing denominators. To rationalize means to turn a number from irrational into rational. Denominators are, of course, the bottom half of a fraction. Okay, so let me give you a very simple example. The numerator of this expression is a rational number, 7. It's actually also a whole number, right? The denominator, the square root of 2, is an irrational number. If you look back at page 607, it explains to you that in order for an expression to be fully simplified, you cannot have an irrational denominator. So what that means is that we need to think of a way to turn this denominator from irrational into rational. The only thing that you can do with expressions is either multiply by 1 or add 0, or other things that, with PEMDAS, that you follow the order of operations, right? But if you have something that has no multiplication signs, no division signs, no addition or subtraction, and you just want to tinker with it, you can only ever add 0 or multiply by 1. So we can multiply by a form of 1 here. The square root of 2 divided by the square root of 2. This is a form of 1. So numerator times numerator. Denominator times denominator. Notice the square root of 2 times the square root of 2 is 2. So that's it. That's how you rationalize a denominator. Of course, I gave you a very simple example. The examples do get harder. So let me put up some problems that resemble the problems from the MyOpenMath problem set. Okay, so I have chosen question 19, question 21, and question 22 for starters. Question number 19 has the square root of 7 in the denominator. Before you multiply this by the square root of 7 over the square root of 7, in math you can save yourself some time and headache by observing the problem before you start. That is, look before you leap. Notice that 14 divided by 7 is 2. So using the quotient rule, we can actually combine the square root of 14 divided by the square root of 7. 14 over 7 is 2, so we could rewrite this as the square root of 2 times the square root of 2. So these combine. And now you have the square root of 2 times the square root of 2, which is of course 2. So I didn't use the process of rationalizing the denominator there. I made an observation that I could get around it and save myself some time. So please look at a problem carefully before you get started to see if there's a faster or a slower way of doing the same problem, and choose the faster way. Okay, for question number 21, I just wrote down part A. So here, the square root of 10. Obviously, there's nothing in the numerator that we can use to simplify this. So instead, what we want to do is think about what is the smallest perfect square that 10 divides into. Because we want to turn the denominator into a perfect square, the square root of a perfect square. And the smallest number that 10 divides into would be 100. Okay, the smallest number that's a perfect square that 10 divides into is 100. So 10 times 10 is 100. What that means is I need to multiply by root 10 over root 10. Now, if you think that was a complicated explanation as to why I chose root 10, I'm going to use that same explanation over in question 22, and it will make a little bit more sense. This then simplifies very quickly. Root 10 over 10. You do need to show this work whenever you are rationalizing a denominator. Show what you are multiplying by. Okay, now for question number 22, it's not going to be sufficient to simply multiply by cube root of 5 over cube root of 5. Because cube root of 5 times the cube root of 5 is the cube root of 25. And the cube root of 25 will not simplify to a rational number. So instead, you need to think of what is the smallest perfect cube that 5 divides into. The smallest perfect cube that 5 divides into, let me say that again. The smallest perfect cube that 5 divides into is 5 cubed, or 125. So what we want is 3 copies of the 5. So if you want to actually write it out with 3 copies, that's fine. Alternatively, you could just write cube root of 25 over cube root of 25. It will achieve the same effect. So whether you choose to write it this way, or if you choose instead, you can multiply by cube root of 25 over cube root of 25. These are identical. Either way, the result, the simplification for both is going to be the same thing. Cube root of 25 over 5. Now, for part B, it would actually be a waste of time to do cube root of 4 over cube root of 4 times cube root of 4 over cube root of 4. Okay, so what I'm about to do, don't do this. You can simplify it this way, but this is the long way. It's preferable if you do not simplify using the long way. You want to learn to go the short way. And so this is where you want to look before you leap. Ask yourself this question. What is the smallest perfect cube that 4 divides into? The answer is not 4 cubed. The answer is not 64. The smallest perfect cube that 4 divides into is 8. So by multiplying simply by cube root of 2 over cube root of 2, notice I get the cube root of 4 times 2, the cube root of 8. This intermediate step is not required. I just want to show you very clearly. Numerator times numerator, denominator times denominator. The cube root of 8 is 2. Okay, so I have put up a few examples, so what I'd like you to do is go ahead and pause the video when I step out of frame and try each of these ones on your own, and then I will put the explanations for each underneath. Okay, so now I have worked through each of these. My advice is that before you get started on any one of these problems, not only look before you start, but see if there's anything you can do to simplify the problem before you move on to rationalizing a denominator. So in this case of question number 29, part A, the square root of 48 can be simplified because it's 16 times 3. We end up with 4 root 3. And then 6 divided by 4 further simplifies into 3 over 2. So simplify as much as possible before you start the rationalizing the denominator step. Here we have the square root of 3 divided by the square root of 3, which is a form of 1. Notice then that the square root of 3 times the square root of 3 becomes 3. These 3's cancel, leaving you with the square root of 3 over 2. For question number 30, there was nothing I needed to do to simplify before I got started, so I went straight to multiplying by root 14 over root 14. So this one's actually a pretty simple one, and you end up with 1 over 6 times 14, which is 1 over 84. By the way, oh, I totally did that wrong. Let me correct that. The interesting thing is the way I realized my answer was wrong just now is when I looked at the original problem. The original problem is clearly an irrational number, and yet my final answer that I had written, 1 over 84, was a rational number. And I knew that an irrational number could not be equal to a rational number, and that's what actually gave it away. But I was about to just suggest that if you want to check your answer, you can use the calculator. So what you do is, going back to this previous one, for example, you can type 6 divided by root 48. So 6 divided by the square root of 48. So if you can see that, here's my screen. I have 0.866 blah blah blah. So now I will take the exact same, now I will take the answer I had over here, the square root of 3 over 2, and I'll see if I get the exact same answer. Look, I got the answer right. You can do this too. You can check right there on the spot to see if the original problem is equal to the simplified answer that you come up with. Okay, question number 31. First, I split root 16 over 7 into the square root of 16 divided by the square root of 7. Square root of 16 simplifies into 4 over root 7. Then I multiplied by root 7 over root 7, giving me 4 root 7 over 7, so that one was pretty straightforward. Number 32, I simplified the x cubed, the square root of x cubed, into x times root x. Then root 13 times root x is root 13x. X times root x is x times x, which is x squared. You don't have to show this kind of intermediate step. You can go straight from here to here. But make sure you do show, when you're multiplying a numerator and denominator by something, make sure you show me what it is you're multiplying by. So that covers our lesson, and hopefully it's pretty straightforward. But MyOpenMath, remember, also has videos posted with the problems. So if you need help with specific problems, most of them have videos posted, so you can follow along there. All right, I will post more videos hopefully on Wednesday, at least in time for next Monday's lecture. These videos right here are for the 25th, and what I'll be posting later this week will be the videos for next Monday, so that you can always be working ahead if need be. Make sure you read the syllabus through if you haven't already, and again, I highly advise that you watch the video that I posted that goes along with the syllabus. Have a great week, and email me if you have any questions. Bye.